share some work so that you can do at home. I think I just have something that we can dive into without wasting some time. Let me quickly share my screen. I don't want this. I want this. Yes. Can you all now see my screen?
Yes, sir.
Yes,
Oh,
sir.
okay. Thank you. I had two people. I had two people right there. What about others? Can you guys see my screen?
Yes, sir.
Oh, fine, fine. I love today's energy, guys. It's better than the last week one. So, yeah, we are having these solving geometrical problems. These techniques in on the screen there that I want us to first quickly look on. So there they are saying, let me just zoom this a bit. Is it fine, guys? Like the size of the zooming, can everyone see? Or should I zoom out a bit or zoom in a bit? Is it fine?
It's okay, sir.
Yes,
Okay.
sir.
All right, all right. Thank you, guys. So now I've got this. Let me just remove this out of my screen. Okay. They are saying here, solving geometrical problems. Nah, right there they are saying. The following exercises involve the use of all the theorem established thus far. So in this problem, on these steps that we are going to do, we are going to include every theorem that we did, whether it's tan chord theorem, first theorem, angle at the center is 2 times angle at the circumference, or cyclic quadrilateral properties, or angles in the same segment. Every theorem that we are going to do here. So they are saying that the following strategy can be used when solving riders, whereby riders are the problems. In this Euclidean geometry in grade 11, those circle geometry that you see there are called riders. So step one there, they is saying analyze the RTP. What does RTP mean? It means required to prove or find in terms of angles. You analyze it. Let's say now you're given some lines there. Then now you are required to prove that this is my line A, B, this is my line C, D. You are required to prove that AB is parallel to CD. You should play around your angles such that maybe at the end you have this angle is equal to that angle. Then you can say now that's the converse of the reason alternate angles. Then now instead of stating those parallel lines, you are going to state those equal lines that you worked through. Or you can just say this angle, let me change the color. You can say this angle plus that angle. If you get 180 degrees, you simply know that's the converse of cointerior angles, because cointerior angles are supplementary. Then you state those supplementary angles. Or if you found that this angle is equal to that angle, that is going to be a converse of the corresponding angles of those lines. Then now instead of stating those parallel lines, because you can't state those parallel lines and say AB is parallel to CD, because that's what you are required to prove. So you are going to state those equal lines, I mean those equal angles. That's the converse of corresponding angles. Then you can conclude by saying now therefore AB is parallel to CD. Does that make sense, guys?
Yes, sir.
Okay, thank you. I got the feedback from one person. I'm not sure if the rest of you guys understand what I've just explained on step number one. Are you guys fine with step number one?
Yes, sir.
Yes.
Okay, fine. Then number two says pay attention to the keywords given. Oh man, they give us keywords a lot. They give us maybe that AB is the diameter. I mean, AB is equal to BC. What something maybe B bisects the line AD, then now you know that bisects. What does that bisect term mean? Bisects mean if part A bisects part B, that means that part A cuts part B into two equal parts. So you should pay attention to those keywords and note them down on your working. Then look for information in the diagram which might prove useful. Then if maybe you are given that this is equal to this, you can work out something there. Just like, let's say now you have your circle here, you have the center, you are given that. We have got O, you have got A here, you have got your B. What you can note here, you can note that this and this are equal, the reason being radii. Therefore, what you can now do, what can you do with that information? Make that information useful. This OAB is a triangle, and these lines are equal. Therefore, this angle will be equal to that angle. That is a very useful information. Therefore, now you can get that angle if you have this angle and this angle working around the summation of angles of a triangle. Fine. Oh, you can use colors if you have colors, or you can use pencil. Then I think to add on this, please guys don't forget to use this technique when you approach these riders. DRCPT. I will emphasize it again. What does this mean, Dr. Cape Town? DRCPT. You first look on your diagram whether there is a diameter. If there is a diameter, you know that theorem that involves a diameter, which is angle in a semicircle one. If there exists some diameter, let's say this is our diameter, then you know that this angle will be 90 degrees, reason being angle in a semicircle. Then you are done with that. Then you go for R, which is the radius. It will be what I've just said now, that if you have this, you can highlight this that are equal, and this are equal. Make that a useful tool, guys. And then we can proceed to C, which is a cyclic quad. Let's say now we extend some line here, that is A, B, C, and then D. Now you know the properties of a cyclic quad, that this angle and this angle will add up to 180 degrees, reason being opposite angles of a quadrilateral, a cyclic quad, not just any quadrilateral. Opposite angles of a cyclic quad are supplementary, and again angle A and angle C will be supplementary, reason being opposite angle of a cyclic quad are equal. Then there is also this line extended on AB. Then you can now say that angle, this one is equal to this angle, reason being exterior angle of a cyclic quad is equal to interior opposite angle. And then you are done with the cyclic quad. Then when I was explaining someone, I think this cyclic quad thing to someone this week, I said this bow tie shape that I mostly emphasize, whereby we know that reason for this angle is equal to that angle, reason being angles in the same segment, or angles subtended by the same chord, or angles subtended by the same arc. Then this is the family of a cyclic chords. So you can also look for it here if maybe you are given some bow tie shape, something like this, and then you can work some angles out. Then you note that this angle will be equal to that angle, and then same applies with the other one of the bow tie on the other side will be equal to that one. And then you are done with the cyclic quad. Then if there exist parallel lines, then you can go for maths is fun technique. For maths is fun technique, whereby if this line is parallel to this line, this angle will be equal to that angle, reason being corresponding angles. Then you state your parallel lines. Same applies with you, this angle, but now they are not equal with cointerior angles. That plus this is equal to 180 degrees. With cointerior angles, those angles that are inside the U are supplementary. Then we go for N, then this angle is equal to that angle only if this line is parallel to that line, reason being alternate angles, then you state your parallel lines. Then lastly, with this one, you can have x, which is the vertically opposite angle. This angle will be equal to this angle. And then as well as this angle, this side will be equal to this angle, this side. Then you are done. Then if they are no parallel line, you can proceed. Now the last one is the tangent, whereby if on the circle you are having the tangent, this is the circle, then this is the tangent, the tan chord theorem. How are you seeing which angle is equal to which angle? I said to you the angle now that is between the tangent and the chord. The angle between the tangent and the chord is equal to the angle that is opposite that chord of focus that we talked about, tan chord theorem. Then the other theorem of the tangent is that if this circle have got the radius there that is going to intersect with the tangent, there at the intersection we're going to have perpendicularity there. Therefore, reason is going to be radius is perpendicular to tan, or you can just write it rad is perpendicular to tan. Okay, then you are done with Dr. Cape Town analytics. Then you can dive into the question. I think most of the question will be answered. And then, does it make sense, guys, to you? This DRCPT technique, or there's anyone who's lost when I was explaining some things?
Can you explain it again, sir? Because I wasn't here.
Okay, I was emphasizing this DRCPT thing, sir. DRCPT. Because, oh, okay, in fact, let me start with the whole step. So, we are here on step 2. We are saying pay attention to the keywords given. Look out for the information that you are given using those keywords, and work out something using that information that you are given. You can use colors, you can use pencil, you can use the most important technique, DRCPT, Dr. Cape Town. DRCPT, Dr. Cape Town, Dr. Cape Town. This is DRCPT. Then such that if you are given a circle whereby D in DRCPT, we know D stands for the diameter. So if there exists some diameter, you already know that there is that thing angle in a semicircle, yes. Therefore, you can highlight that angle. Maybe it might help you somewhere, somehow. So you highlight it there, maybe using your pencil that, oh, that angle there is 90 degrees. Reason is going to be angle in a semicircle. Fine, you are done with D. Let's proceed to R, the radius. Maybe you might given something like this. If this is the center of the circle, then let's say this is our A, and then this is our B, this is our C, and then you are given some D here, and such that there is a chord DC that exists here in this circle. Then you can use this information. These are radius, radi, OC is equal to OD. This is an isosceles triangle. Now you can highlight that this angle is going to be equal to that angle. Then if you have this angle already and this angle, you can work out that angle there. Okay, then we are done with that. Then C, a cyclic quad. If maybe it happens that we have something like this, A, B, C, D, it's a cyclic quad. You can work around your properties of a cyclic quad, whereby you know that opposite angles of a cyclic quad, note that not any cyclic quad are supplementary. What do we mean by supplementary? We mean that when you take that angle, you add to this angle, you're going to get 180 degrees. Same applies with C and B. These angles are supplementary. What do we mean by that? When we add C to B, we get 180 degrees. Then this is one of the properties of a cyclic quad. When we extend the line CD, we are going to have this angle. Let me just quickly change the color to maybe the different one. This angle is going to be equal to that angle. Reason being, exterior angle of a cyclic quad is equal to interior opposite angle. Fine. Then I emphasized this to someone I think I was explaining the properties of a cyclic quad during the day here. So I said this bow tie shape that I always emphasize, whereby you know that this angle is equal to that angle. This angle is equal to that angle. Reason being angles in the same segment, or angles subtended by the same chord, or angles subtended by the same arc. This is one of the family or family member of the cyclic quad. So don't forget it when you're working with this C in the Dr. Cape Town technique. Try to find it if it exists there, and then work out those angles that are equal. Then if you are done with the cyclic quad, you can proceed to P, which is parallel lines. So if parallel lines exist there in that question, just quickly jump into the maths is fun technique. Maths is fun, and it's fun indeed. So if this line is parallel to this line, this angle will be equal to that angle. Reason being, corresponding angles are equal. Then you state your parallel lines. So with cointerior angles, now note that they are not equal, but they are supplementary. Meaning if you take this angle plus that angle, you are getting 180 degrees. Reason being cointerior angles, then you state your parallel lines. Then if this one now is parallel to this one, this angle is going to be equal to that angle, reason being alternate angles, then you state your parallel lines. Then lastly, with this fun, maths is fun, we can have that one, but this doesn't necessarily need parallel lines. As long as you have some intersection of lines, you can say this line, this angle is equal to this angle, vertically opposite angles, and then this one is going to be equal to this one, reason being vertical opposite angles. Then you are done with the parallel lines. You can go to T, the tangent, whereby you're going to apply the, no, this is not the tangent, sorry. Where is the tangent? Let me redraw my beautiful circle. This is the tangent. Then that is a triangle, whereby this angle here, this one is going to be equal to that angle, reason being tan chord theorem, or this theorem. It also there. Let's remove this. Oh no, I want that circle of mine there. Now let me just redraw it. This is the circle, this is the tangent, this is the radius. Then if this is the radius, if this is a tangent, at the intersection there will be perpendicularity. The radius will be perpendicular to tangent. Then you are done now analyzing. Then you can dive into the questions. I think that will work out for you guys. So does it now make sense to you? Are you fine?
Yes, sir.
Okay, thank you. Then let's go to step 3. They are saying brainstorm and develop a rough proof. I think where required, you can do so and then write a formal proof. If you are required to prove something, as I've said, I think I've said this, guys. If you are required to prove something, you need to know the properties of that thing. If you are required to prove the parallelogram, you need to know the properties of a parallelogram. If you have like parallelogram, opposite angles of a palm are equal, opposite sides of a palm are equal and are parallel, then you work around that. Then you can conclude by saying this quadrilateral is a parallelogram. Cyclic quad. If you are required to prove a cyclic quad, you need to know the properties of a cyclic quad. Properties of a cyclic quad is that opposite angle of a cyclic quad are supplementary. That's the property. Then the other one is that one, that exterior angle of a cyclic quad is equal to the interior opposite angle, or the bow tie shape one angles in the same segment. Then information and the keywords mind map for the riders. Then when parallel lines, I think this is the summary of what I've just said using Dr. Cape Town. So I'm not gonna just read this because it will be a waste of time repeating what I've just said there. So this is the reminder of that maths is fun thing. I think I also said this. And then this is vertical opposite angles. These are I think adjacent line angles on the straight line. Then we can move to this, whereby it emphasizes this step here, this one, sorry, it emphasizes this step here, whereby they say pay attention to keywords, to some words like something is parallel to something, something bisects something. So you need to know what does bisect mean. Here they are saying if BD is said to bisect the angle B, then angle B1 is going to be equal to B2. Because remember, bisect means it cuts that thing into two equal portions. Same applies with the line. If the line bisects other line, it means that line 1 cuts line 2 into two equal portions. Therefore, if line CD bisects a line AB, it means AD will be equal to DB. Then this is the triangle information. We have been saying this, guys. This is an isosceles triangle. Isosceles triangle is a triangle whereby there are those two equal lines. Then now you can conclude by saying, what's now happening? You can say this is equal to that, reason being angles opposite equal sides or base of isosceles triangle. You can see this a lot whereby, oh, this is a circle, and then they say this is the center of the circle, this is the radii, then this angle will be that, will be equal to that. Then you can work around your maths to work out something. Then also this property, I think, is very, very important, guys. It's a very powerful tool that you can use in Euclidean geometry. You need to know that this angle is equal to the sum of that angle, reason being exterior angle of a triangle is equal to interior opposite angles. And then, oh, here they are emphasizing what we have been knowing, I think, since grade 7, that when you take this angle and this angle and that angle you add, you're going to get 180 degrees. Reason being, interior angles of a triangle are supplementary, or sum of the interior angles of a triangle. Then we can proceed to this triangle, which is the equilateral triangle. I think this one by this part tells us what is it. Equilateral triangle is a triangle that have got all sides are equal. It's in the size. I mean, if this size is said to be the size of 6 centimeters, this one as well will be 6 centimeters. This one as well will be 6 centimeters. Same applies with angles. All angles are going to be equal. And I don't think there's any other way whereby these angles can be of different size. I think with equilateral triangle, they are always all 60 degrees. So anyone with a question regarding what I've just explained, guys? Oh, you guys are cool. We can proceed to the next part.
Understood, sir.
Okay, Ethan understood. What about others? Any feedback, guys? Did you guys understand? Or
Yes,
you
sir.
guys did not understand? Okay, thank you. Then we can proceed to part 5, which is just, I think, the summary of those things that we just did. Then and this one is that theorem 2. Oh, this one are very, very basic questions. I think we can just move from here to the questions. This is the summary. This is the summary of what we know. Then let me quickly jump into the problems. I don't want this, and I don't want this. Maybe this one, maybe. Oh, then you can at least maybe let me zoom out a bit. Okay, let's me do this. We have number 3. So the statement here with number 3 is saying O is the center of the circle. O is the center of the circle. Then, and AB is the diameter of, then we can simply say DRCP. Dr. Krypton. Oh, D, they are saying AB is the diameter. Then, we can simply see that angle C, the whole C, is 90, excuse me, is 90 degrees, reason being angles in a semicircle. Then, we are done with the diameter. Then R, which is the radius of the circle. This is the radius. This is the radius. This angle will be equal to that angle, reason being angles opposite equal sides or base of isosceles triangle. Same applies with this one as well. This one here and this one, radii. Then this angle is going to be equal to that angle, reason being angles opposite equal sides or base of isosceles triangle. Then I think we are done with the radius because there is no tangent. You can't say the radius is perpendicular to tan while there is no a tangent. Then a C, a cyclic quad, I think I can see that part I've emphasized. That is the family of the cyclic quad properties. That this angle is equal to that angle and this angle is equal to that angle. So, okay, cool. Then I can see it here. Here it is. Here it is. Then we can see this angle is equal to this angle and this angle is equal to this angle. Fine. We are done with the cyclic chord. Then P, there are no parallel lines. Okay. T, there is no tangent. Okay. Then we are also given AOC. This angle is 104. Okay, and we can get this from that 104. Okay, and DAB, DAB. Where is DAB? DAB, here it is. DAB is 32. And then we said this 32 is equal to angle C3. Therefore, this will be 32 as well, reason being angles in the same segment, angles subtended by the same chord AC, or angles subtended by the same arc AC. Oh, fine. We are done with the analysis. Let's dive into the questions, guys. Then now we are required to calculate the size of angle D. So angle D, guys, we can see that angle D is this one. And then we were given AOC as 104. Now we can go for the theorem. Angle at the center is 2 times angle at the circumference. So now our angle D is going to be 2 times, that angle at the center, we divide it by 2 because now we want that angle at the circumference. So it's going to be 104 divided by 2. Therefore, we are going to get 52 degrees for that one. Oh, nice. And then the next one, we are done with this. Now we want C3. So what's now happening? Hi. Oh, hello guys. My apology. My system just crashed out this side, and I'm sorry for that. I'm back. I'll just try to recover that time maybe with the last 10 minutes after this hour. Can you all hear me? I'm now back, guys.
Yes, sir.
Okay, thank
Yes,
you.
sir.
Let me quickly share back the screen. I'm sorry, guys. I'm sorry. Let me. Can you now see what I'm now sharing? That side.
Yes, sir.
Okay, thank you. So we worked this angle. We got 52 for angle D. We got 52 for this angle. And then now D, okay, we're done with D. We want C3 now. Where is C3? C3 is here. And then how can anyone guys in the room who can tell us how can we find that angle C3? Anyone is in the room who can tell us how to find the size of angle C3? And I think I gave you the hint that this angle is equal to that angle. Yes, we did say that. We did say this.
It's 32 degrees.
Is 32? Why? Reason behind that?
Angles in the same segment.
So they said DAB, or they said this one, yes, this is 32. I agree, yes, that this is 32 degrees and it's in the same segment, fine. Then we go now for A1. Where is A1? Oh, here is A1. I think I can give this question 3 marks. So anyone with an idea, guys, of how we can get A1? I think I also gave you some hint that this angle is equal to that angle, reason being this is a radi and that is radius, then angles opposite equal sides. So now guys, how do you think we can find the size of that angle A1? Anyone with an idea, guys?
Sum of a triangle.
Yes, absolutely. Then we are going to get, I think, 76. You divide that 76 by 2. I get 38 on my side. I don't know about your side. Is that correct, guys? I get 38 for both angles. Can you just quickly please confirm on that on your calculators? Is that all right?
I got 52.
You got 52. You're saying you got 52. Did you
I
just say
also got 52.
for A1?
Yes, sir.
How did you guys get 52? Okay, maybe I made some mistake, but look, this is what I did. Okay, we are having 104 here. AOC, we're having 104 here. So 180 minus that
Oh, I
104
see, sir.
minus we get 76. Then that 76 you divide it by 2, you get this 38 for this one, you get 38 for this one as well. You now get it?
Yes, sir.
Yes, sir.
Okay, thank you guys. Okay, thank you. Then we are done with this one. Let's go for C2. C2 is this one here. Remember, initially we noticed that this angle is 90 degrees, everything here. And then we can just subtract that C3 that we found here. And then we can subtract this C1 here that we know that is 38. Then we can be left with that C2. Then you are done with every question that was required from you. Does that make sense, guys?
Yes, sir.
Yes, sir.
Okay, thank you, guys. Please, guys, don't forget to just shout out if I'm leaving you behind. Then now, let me just find some question. Okay, let's maybe work around this one. This one I want to work through it with you guys. I just don't want to give some hints. I don't want to do anything. I just want to read the statement and then now we discuss the value of the size of these angles. They are saying PQR is a tangent, guys, at Q in this circle. Fine. And then now we are also given that ST is parallel to QW. ST is parallel to QW. Oh, that can help us a lot. That's a very powerful information. WQR is equal to 30 degrees. Okay, where is 30? WQR. Oh man, that is an angle between the tangent and the chord. Wow, okay. And then we have TSW. We have TSW as 70 degrees. Okay, we can use that. And then now calculate the size of the following angles with reasons. What is the size of angle V, guys? Anyone who can tell us how to get the size of V and what is the size of B, giving some reasons. Anyone, guys? Or are you guys maybe still thinking of how you can do this? Are you guys still there?
Yes, sir.
Okay, Oneide is still there. I'm not sure about Ethan. I'm not sure about Serena's iPad. I'm not sure about Lavela. I'm not sure about Naledi. Are you guys there?
Yes, sir.
Okay, Ethan is there. Lavela, are you there?
Yes, sir.
Oh, thank you, sir. Thank you. And then I think we are left now with is it Naledi? Naledi is there? Serena's iPad. Are you guys still there? Oh, you guys are also still thinking of how you can get the V. V is there. V is this one, guys. V is this one. Yeah, so that is why I will always encourage the technique DRCPT, guys. DRCPT. Let's all together work around this problem. D. So this is my question to you guys. Is there any diameter on the circle that you're having on the question?
Yes, sir.
Where is it?
SW.
Why are you saying that is a diameter? Because remember, in Euclidean geometry, I think we support what you've said using some geometrical reasonings. So if you are not given that something is something, you need to just accompany that statement with some reason, I think. So what's the reason behind that statement that SW is a diameter?
Exam Ezekiel.
Hmm. I disagree. I disagree. I disagree. So I disagree. So I somehow disagree because I think you were supposed. This is what you're supposed to say. If you are given that this is, if you are given, I want you to hear me this. If you are given that SW is a diameter, that's when you can say this angle is 90 degrees. You accompany that with a reason that is saying this is a semicircle. Only if you are given that SW is a diameter. Or now, if you are given that angle Q2 is 90 degrees, then you can say SW is a diameter. That is the converse of the reason angle in a semicircle. Does it make sense?
Yes, sir.
Okay, thank you. Therefore, there is no a diameter in this diagram. So you can just scratch it out. And then this circle doesn't have a center. So obvious, there won't be any radius in this circle. Then a cyclic quad. Yes, there exists a cyclic quad. Here it is. You know the properties of a cyclic quad. If you take this angle here, this one plus this one, 180 degrees, supplementary angles. This plus this, supplementary, 180 degrees. Fine. Also, this one is a cyclic quadrilateral. This one is also a cyclic quadrilateral. This angle plus that angle, 180 degrees. This angle plus that angle, 180 degrees. Fine. We are done with that. And then P, are there any parallel lines? Yes, there are parallel lines in this. Then we can go for a match is fun technique. F, oh, we can't use F, but we can use U. Maybe, yes, U. This angle plus this angle, 180 degrees cointerior angles are supplementary. You state your parallel lines. Then same applies with this angle and that angle cointerior angles. You state your parallel lines, and those cointerior angles are supplementary. And then you can also go for Z or N alternate angles. This angle is equal to that angle right there, alternate angles. Reason being, alternate angles, ST is parallel to QW. And then who is the other one? Okay, I think that's all with the parallel lines. Then the tangent, there is a tangent. This is the angle between the tangent and the chord. Then that angle is going to be called the angle that is opposite the chord, I mean. So this angle is 30 degrees using a tan chord theorem. Fine. And then, that angle, is not equal to that angle. And then what can we use with tan again? We can say radius is perpendicular to tan because there is no radius. Fine. Now let's go to the question and see how we can. I think we answered that. So we said STVW is a cyclic quad. So S and V are opposite angles. And then when you take S plus V, you're going to get 180 degrees. Therefore, angle V is equal to 110 degrees. Reason being, opposite angles of a cyclic quad are supplementary. Does it make sense, guys?
Yes, sir.
Okay, thank you. I think I had feedback from only one person. Does it make sense to everybody, guys?
Yes, sir.
Yes, sir.
Okay, thank you, guys. Thank you. Then we are saying this angle right here, it's 110 degrees. Fine. Then the next question, Q1. Where is Q1? Q1 is this one here. Okay, using time code, this one is going to be equal to that one. And then now, say, these are parallel lines. This angle is equal to that angle. Therefore, this is 70 degrees, reason being alternate angles. Then ST is parallel to QW. Therefore, W1 is equal to Q1, reason being tan chord theorem. Does number B make sense to you guys?
Yes, sir.
Okay, thank you guys.
Got it.
Then we can go to
So
The next one, sorry? I thought you wanted to say something, but okay. And then T1 now. Why is T1 is this one? This one. Anyone, guys, with some idea of how we can find that angle T1? Anyone, guys? Give it a try. I mean, don't be afraid to be wrong. You are wrong. We correct that. I mean, we don't laugh at each other. We just having fun around maths. I mean, anyone with an idea of how to get angle T1? Anyone, guys? Oh, are you guys still there?
yes, sir.
Okay, so I was asking, is there any one of you guys who have got some idea of how to find that angle T1 there? But it seems like, I mean, I think you guys are still enjoying the weekend or you are still analyzing the problem, but I think we did this, guys. We analyzed this using this DRCPT. But do you agree, guys, if I say this is a cyclic quad? Do you guys agree?
Yes, sir.
Okay. Then if that's the case, do you agree if I then now, guys, say, let me just subtract this. Do you agree if I say this angle here is 80 degrees? Do you agree?
So why is it 80 degrees?
Okay. Let me ask you this question. What is the size of angle Q1?
It's 70.
It's 70. Yes, it's 70 degrees here. So we have this 70, we have this 30, and then 180 degrees on the straight line, minus 30, minus 70. Then you're going to be left with 80 degrees. Does it make sense, Oneile?
Yes, sir.
Okay, thank you. Then, if then you guys agree that this is a cyclic quad, then this is opposite this. And then now, what is going to be the size of angle T1, guys?
100.
Absolutely correct. Yes, reason being, opposite angles of a cyclic quad are supplementary. Then now, what is the size of angle W2?
10.
Sorry?
10.
Oh, yes, 10 degrees. Yes, reason being,
Sum of triangle.
absolutely correct, sir. I thank you. That's 100% correct. Anyone we've got some question on how we did one of these questions? Anyone who's still curious or anyone who was left behind? Are you guys okay?
Yes, sir.
Okay, thank you.
Understood, sir.
Okay, thank you, thank you. Then now, let's do this as the last question. Wow, we have to prove. We have to prove. This is the last question. Then what are we going to do next week? Oh, next week we will be focusing on these complicated questions, these ones. I think we're almost there, guys. Oh, but still a long way to go. Oh, we would end up doing these questions. These are the questions that I want you guys to be perfect with. But without wasting some time, uh, where were we? We were somewhere. Okay. Oh, we're here. They are saying now number 6. O is the center of the circle, ABC. ABC is the circle. AC is produced to D, boom, so that DC is equal to BC or CB, whatever. Oh, by this, we can see that CBD, what's that? It's an isosceles triangle. Therefore, this angle will be equal to that angle. Oh, fine. And then now we can also see that this is the radius and this is the radius. But okay, it won't help us because we don't have the line AB. Okay. And then what else? Oh, this angle here, using that property, this angle is equal to this plus this. Therefore, we can see now here in this case that this angle is the sum of those angles. Okay, and then now let's continue. Prove that O1, wow, O1 is this one, is 128 degrees. If D is 32 degrees, then if D is 32, if D is 32, oh, this question is nice. I think this question is not bad. So if this angle here is 32, that angle as well will be 32 because of that equality here of the lines. Do you guys agree to this?
Yes, sir.
Okay, thank you. Then now we can get this angle as 64 degrees, reason being exterior angle is equal to the sum of interior opposite angles. Do you guys agree to the size of angle C1?
Yes, sir.
Okay, thank you. Then the size of O1 now is going to be 128, reason being angle at the center, because this is the center, is 2 times that angle at the circumference of the circle. So does this make sense to you guys?
Understood, sir.
Okay, you understood. What about others? Does it make sense to you guys?
Yes, sir.
Oh, no, it makes sense to Naledi. What about you, Oneile, Lavella? Does it make sense to you guys?
Yes, sir.
Oh, and then Lavella. I didn't hear some
Yes.
feedback from you guys. Okay, thank you guys. Then we are done. I think we can end here for today. Unless you guys have got some questions that you want to ask, then so that I can answer before we log out of the lesson. I'm going to give you guys some work to do there at home, and I think this question, I think there is going to be a lot, not even a bit, a lot. So, anyone some question, guys? Or you guys are fine?
No question, sir.
Okay, guys, I thank you for being with me tonight. I think this will be the end of today's lesson. I will see you guys next week. Enjoy the rest of your weekend, guys. And I will send those questions. So please, guys, check that channel on WhatsApp. I will drop these questions in there. So please check them out. Have a good night.
Good night, sir.
Thanks, ma'am.